This is one of the worst cases to modify your guess for because it gets rather annoying and tedious no matter how you do it. So this method of undetermined coefficients, we have y double prime plus 4y equals 13 sine 2x. If you find the characteristic polynomial for this, the roots are plus or minus 2i. And so the homogeneous solution is c1 times cosine 2x plus c2 sine 2x. Now that's going to be a problem. So right for y particular of x, since this is a constant times sine 2x, we would normally guess some undetermined coefficient a times cosine of 2x plus some other undetermined coefficient b times sine of 2x. But that's a problem because that's exactly the homogeneous solution. Some constant times cosine 2x plus a different constant times sine 2x. So if we plug this into the differential equation, the whole thing is just going to disappear. We'll get 0 equals 13 sine 2x. So what do? We multiply by x. Then we take the derivative. Now it's up to preference here, but I prefer to multiply it out first. It just kind of keeps things a little more separate. So in here, I'll write this as ax cosine of 2x plus b x sine of 2x. And now we get to do a bunch of product rules and chain rules and trig derivatives. So we get y particular prime of x equals, well, that's a times 1 times cosine of 2x. And then we're going to have actually a minus. So derivative cosine is negative sine. So there's my negative. And we're going to get a 2 to pop out. So here, let's just do a times x times 2 sine of 2x, where I put the negative in front there. Okay, that's the first bit. Now I have the bx times sine 2x, so plus b times 1 times sine, close enough, of 2x. And then plus the other half of the product rule, so this one ends up being plus, we get bx times 2 cosine of 2x. Right, 2 from the chain rule, and then its derivative of sine turns into positive cosine. Now it's really nice to simplify at this point so we don't have as many chain rules. You know, we can cut down a few. So here I have cosine of 2x, and I don't know how many terms I'm going to have, so I'm just going to make the parentheses probably bigger than I need to. So I have cosine of 2x, then plus, not sure how many terms I'll have, but I'll have sine of 2x. Now let's see here, I've got a times cosine, so there's an a, and then I've got minus 2ax sine 2x, so minus 2ax. Then I've got a plus b sine 2x, so plus b. And then I've got a plus 2bx cosine 2x, so plus 2bx cosine 2x. And we get to do it again, so y particular double prime of x equals, all right, so take the derivative of this, we'll end up with, let's see, 0 plus 2b times cosine of 2x, and the other half of the product rule, that'll end up being a minus 2, derivative cosine is negative sine, 2 pops out from the chain rule, times the a plus 2bx times sine of 2x. All right, so that's the first term. Now we have to do the last product rule, the second one. I've got a plus, let's see, I've got negative 2a plus 0 times sine of 2x. And then I'll end up with a plus 2. Derivative of sine is positive cosine, so 2 from the chain rule. I've got negative 2ax plus b times cosine of 2x. And again, it's nice to lump things together before we put it into the differential equation. I don't know how many terms I'll need. I'll just give myself more room. So cosine 2x plus, I don't know how many terms, times sine 2x. Okay, we've got a 2b cosine, so 2b, and then we've got a minus 2a sine, and also minus 4bx. Okay, and then we've got a negative 2a sine, so minus 2a. Then I've got a negative 4ax cosine, so minus 4ax. And then I've got a plus 2b times cosine. All right, so now I get to add these together. Oh, all right, so y particular double prime plus 4y particular. This would have been even worse if there was a middle term. Thankfully there's not. So let's see here. All right, I have a big parenthesis for the cosine of 2x plus another really big parenthesis for the sine of 2x. All right, so y particular double prime, I'm pretty much copying the line right above it. So I have 2b minus 4ax plus 2b. I suppose I could have simplified that. But then I add to that 4y particular. So this is the cosine term. So I think I end up with plus 4ax cosine 2x. So plus 4ax cosine 2x. All right, and now same thing here, looking at just the signs. So copy essentially what I have right above it. So minus 2a minus 4bx minus 2a again. Then I have plus 4 times y particular. So I get 4bx sine 2x. So plus 4bx. And a nice simplification has occurred. So this ends up being, okay, so 2b and 2b, that's 4b. But the negative 4ax and the positive 4ax cancel, so it's just 4b cosine of 2x. And then for the sine, we have negative 2a, so it's actually minus 4a. But the negative 4bx and the positive 4bx cancel, so it's just 4a sine 2x. And at this point, we can kind of check our work. It looks like, we didn't necessarily make any mistakes. So since all the x terms canceled out, we can actually solve for the right-hand side. So this whole thing is supposed to be 13 sine of 2x. And then, right, it's also plus 0 cosine 2x. And this one looks solvable. So, right, it's not that bad. So it looks like b equals 0. Right, so we have 4b equals 0. So that's going to mean b equals 0. Because, right, there's 4b cosine 2x on the left-hand side here. There's 0 cosine 2x on the right-hand side, so b is 0. We have negative 4a sine 2x on the left-hand side, and we have 13 sine 2x on the right-hand side, so that has to equal 13. So then a is negative 13 over 4. So I have just enough room up here to write out the particular solution. So y particular of x is equal to, the only thing in it are, looks like cosine terms, so we get negative 13 over 4x cosine of 2x. And all right, so after all that work, we're finally done, and this is the particular solution. Right, if you want to get the entire solution to solve for initial conditions, you add the particular solution to the homogeneous, and if you want to solve for initial value problem, you then have the C1, C2 in your entire solution to solve for the initial conditions. But yeah, these can take quite a while.